Now a few starred comments about the Euclidean algorithm. We just showed that the Euclidean algorithm gave that the greatest common divisor of 3, 5, 3, 6 and 1, 2, 7, 5 was 17. If you compute the factors of 3, 5, 3, 6 by hand, you'll end up with the prime factors 2 to the 4th times 13 times 17. And if you compute the prime factors of that by hand, just keep factorising, then you'll end up with 3 by 5 squared by 17. Now we haven't yet proved that prime factorisations are unique, but we're going to do that very soon. In fact, we're going to use the extended Euclidean algorithm, and we're going to use that in the next subsection to prove this fact that prime factorisations are unique. So that gives us that the greatest common divisor of 3, 5, 3, 6 and 1, 2, 7, 5 has to be 17, because 17 is the only common factor. Here the other factors, prime factors are 2 and 13, and here they're 3 and 5. So doing it by hand in this way, we get 17, as we should, because we've got 17 from the Euclidean algorithm. So as I just mentioned, to justify this approach in general, what we need to do is to prove that prime factorisations are unique. And we're going to do that in the next subsection. But we have a much bigger problem if we want the greatest common divisor of big numbers. Remember, big means for us 150, 300 digits. So think of 300-digit numbers. Then the number of steps in the Euclidean algorithm we can show is roughly 300 or so. So that's not much if we're going to do things on a computer. Of course, we have some pretty big divisions in there, but it'll take a fraction of a second, even if we're dealing with 300-digit numbers, for the computer to do 300 steps. No problem. However, if we want to do a direct factorisation, then the number of steps is typically going to be of the order of 10 to 300. So that's, as I said many times, far, 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 far greater than the number of atoms in the universe. In other words, no hope that you'll be able to actually do this with current computing technology. So the idea of finding greatest common divisor by factorising each of the integers a and b when you get to large integers is just not possible.